Hi, I'm Ken. I'm going to be teaching the Principles of Ecology course. And one thing I've always liked about ecology is it's everywhere and even in our own backyards. So I'm in my own backyard right now. My wife Kim is the cinematographer operating the camera. And what we have in front of us is some lady slipper, which is actually the provincial emblem, the floral emblem for Prince Edward Island. But I have it growing here in Cape Breton. It's a beautiful flower. This one's probably going to be about 10 years old because from the time they germinate until they have their first bloom, it can be up to 10 years. And they can live for up to 30 years in the wild, so it's a fairly long-lived plant. This area where we're standing was once covered by brush pile by a former owner, and that created ideal conditions for this plant. So the lady slipper needs acidic soil. In fact, if you water it with water from your tap, which depending on where you live in Canada could have a lot of alkalinity, you can actually make the soil around the plant no longer acidic, and that will kill the lady slipper. So in this class I'd like to talk about all the things in the physical environment that interact with and modify the availability of animals and plants in the biotic environment. So we'll talk a little bit about the lady slipper here. It's really a fascinating story of symbiosis. And symbiosis is when two organisms have to live together or work cooperatively in order to obtain a joint common goal. So many plants will have a flower, and that flower will have nectar as an offering to attract pollinators and a fragrance associated with it. The lady slipper does have a nice fragrance to attract pollinators like bees, but what it doesn't offer is a nectar reward or a sugary water treat for insects to attract them to come. So this plant is really only good for naive pollinators, so a new bee who has never had much experience with a lady slipper before. How they work is if you look carefully here at the inflorescence, the flower, this is one modified petal, there's only 3 petals making it up. There's like an inward facing doorway here that the bee can push its way in very readily, but then it can't get out. In order for it to get out, it has to move up through this part of the plant and exit through a doorway right here. And when it exits through that doorway, it actually picks up some pollen and takes it to the next plant and pollinates it. But in a sense, the plant tricks. It doesn't give a fair reward to the pollinator because it doesn't offer any nectar. So bees will only a few times go into a plant like this. And so this plant entirely relies on tricking or having naive bees that haven't been exposed to a lady slipper before in order to achieve pollination. So that's not a very effective strategy, relying on naive bees. Second part of why this is such an amazing find to have these plants growing here on these acidic soil conditions, and they're made acidic by all the conifers around us. The needles, as they fall and decompose, create acidic conditions. Very common here in Cape Breton Island because of the conifers as part of the forest, boreal forest type. The second thing about this is when it does make a seed, when there is sexual reproduction and a seed is formed, when that seed falls to the ground, it can't survive on its own. It needs to have another symbiotic relationship with a fungus. And that fungus will actually extend the roots out and capture and feed the seed from the lady slipper, which is a pretty interesting phenomenon. So a very delicate reproductive process. And in fact, each one of these plants showing up anywhere is pretty much a miracle. So in the class, what I'd like to talk about this year is the abiotic conditions, the temperature, the rainfall that creates a climate that allows this plant to grow, the acidity from the surrounding ecosystem. So those are all things we'll explore. We'll talk about mutualism, how organisms work together, plants and animals, to achieve common goals. Many plants will use something called extrafloral nectaries, or nectar offerings that are not part of the flower or inflorescence of the plant. These extrafloral nectaries will be there to attract animals like ants, and the ants will wander up along the stem to get at the nectar, but will guard the plant against herbivory. So it's a great kind of mutualism that is exhibited by the plants and the ants. There is a cost, of course, to making nectar, and this plant, this is an orchid actually. We think of orchids as living in very steamy hothouse environments near the equator. This is our orchid of the north here, the lady slipper. And they actually cheat their symbiotic mutualistic partner by not making nectar. So they save themselves a lot of energy by not producing the carbohydrates and the sugar to make that nectar. On the other hand, they're not very efficient at pollination because they don't provide that nectar, so that pretty soon the hosts learn to avoid lady slipper and they don't pollinate them very frequently. So a very interesting part of our flora here in our own backyards. And as we go through the course, I'll try to talk about things in your own backyard that you can see that are part of ecology. And since I was a kid, I've been fascinated by ecology because it's not only something that happens in far northern places or near the equator, ecology does happen in our own backyard.